Alright, so let's go ahead and get started. If you remember from last week, we started this section on Friday. We were talking about the solving rational equations and inequalities. So we went through this page here. We had filled out this table, looked at the graph and the equation up above, and we had questions throughout the notes dealing with the same equation the entire time, answering questions on the front and back. And on the back, we went through this process with the steps listed. We made a number line, and we were able to solve the problem they were asking. So we're going to continue on with this same format. We're going to be able to solve the problem they give us, going through these steps that are listed out. And then after this example, we're going to try to do similar examples without the steps listed out. Alright, so let's go ahead and get started. So number one, it tells us the first thing you should do is completely factor the given rational function, provided that it is not already factored. Do we need to factor it? It's already done for us. It already has the x plus 3, the x minus 1, x plus 2 squared on the bottom, so that's an x plus 2 and an x plus 2, and it's less than 0. So it's already factored. So step 1 is done for us. We don't have to do anything. Step 2, set each factor equal to 0 and find the zeros of the function and the values where the function is undefined. Then we want to draw a number line that is divided into segments using the zeros. So first off, we want to find out what the zeros are. So if we set it equal to 0, or we find out where the function is undefined. Good morning! Does anybody have anything for the office? I don't think so. Thank you. Have a great day. Alright, so if we set it equal to 0 to find our zeros, or where it's undefined, what values would we get? X is equal to what? Negative 3, negative 2, and 1. So negative 3 from up here, if you set that equal to 0. The 1, if you set that equal to 0. And on the bottom, the x plus 2, if you set that equal to 0, you get the negative 2. So I agree with those. Very good. So the second step of step 2 says draw the number line. So let's go ahead and draw a number line. Okay. List the values of x that you had just found, so negative 3, negative 2, and 1. So step 3 says choose a number from each interval and determine the sign of each factor of the rationale based on the chosen value. This will enable you to determine if the entire rationale is positive or negative on the interval in question. So we want to know if it's positive or negative in these intervals here. So again, you're going to choose some value in that interval, plug it into the original, and again, remember from Friday, we don't care what the answer actually is. We don't care about the number value, we just care about the sign. So if we do the first one together to remember how to do it, let's say x equals negative 10. That's within that interval here. So if I plug in negative 10 to the original, negative 10 plus 3, well, that would give me a negative for the first one. Negative 10 minus 1 would give me a negative for the second value. And on the bottom, I would have negative 8, but it's squared. So on the bottom, I actually get a positive. On the top, a negative times a negative is a positive. And a positive divided by a positive is a positive number. So what this is telling us in this interval right here, from negative infinity to negative 3, our answers are all positive. Go ahead and use that same thinking with values in between. You can choose any value in between, but if you want to use the values I used negative 2.5, I use 0, and I use 10. So if you want to use those ones to check your intervals, go ahead, plug into the original, and check whether these intervals are positive or negative. If you want to check with your partner, you can do that too. See, make sure they get the same answers you got. Bless you. Bless you. Okay, on the next section, from -3 to -2, your final answers are negative or positive?
Negative.
Negative, very good. So in that interval, they're negative. This interval between -2 and 1, are your answers positive or negative? Emily?
Negative.
They are negative. And lastly, from 1 to infinity, the answers are what? Positive, very good. Again, we don't care what the actual number value is, we just want to know if our answers are positive or if our answers are negative. So we've done all the work now. Now if we look at number 4, we need to make our conclusion. So, refer to the original inequality sign. In this particular example, the inequality symbol is less than, which means the solution will be the values that make the polynomial negative. Write the solution interval or intervals. So if that's any value that's negative, less than 0 means f of x is negative, so that's what we're looking for. It says it has to be less than 0, so f of x is negative. So referring to up above, what intervals is our function negative? Marie?
-3 to -2 and then
Very good. -3 to -2, union -2, comma 1. Those are the two intervals on which they would be negative. Any questions about that so far? So that really is what we would have done on Friday. Alright, so now refer back to the graph of g of x pictured below. So we have the graph here. Explain how your sign analysis in the process above is confirmed by the graph. So think about your answer. If you want to kind of look back to the way we answered the previous question, maybe you can base your answer off of that, the one we did last week. But looking at your graph and looking at your sign analysis, how can your graph really confirm what we found mathematically? If we have less than 0, graphically, this means what? If you're looking for an answer that's less than 0, graphically, what are you looking for? Yeah, your line to be below the x-axis. So graphically means below the x-axis. And f of x is below on -3 to -2, union -2 to 1. Very good. So just looking at the picture to be able to confirm our answer. So -3 to -2, and from -2 to 1. So graphically it's below the x-axis. Very good. Any questions with that example? Alright, so that was the last one with the steps listed out, so we're going to go ahead and go through the same process, but we just have boxes here without our steps listed. So, step 1, we're looking at this example here, is we need to do what? Step 1. Marie, factor. The top is already factored, we can't do anything. So the bottom needs factored. Can we factor the bottom? No, not really. So if we can't factor, how can we find the x values associated with that? Quadratic formula. So yes, we have to use the quadratic formula. X equals the opposite of b, so -4 plus or minus square root b squared minus 4ac all over 2a. If you simplify, you get -4 plus or minus 2.828 divided by 2. So really we're doing this because we want the x values where it's either equal to 0 or undefined. If we refer to the top, we know what x value makes this 0. What x value makes this 0? or referred to the numerator, because we just want to list out those values. Anyone? What will make the top equal to 0? Okay, if we have 3 on the top, that is going to make the entire thing 0. So one of the x values is 3. And again, the bottom we couldn't factor like we could with the top, so we used the quadratic formula, and we have 2 answers here. So if you find out the decimal version of each of those, you would get negative 0.586 and negative 3.414. So again, those are the values that make it undefined. This is the value that makes it 0. So yeah, it looks a little different than the previous example where we were able to factor everything, but we have the same result. We have our values that make it 0 or undefined. After we find our values, we always make a what? Yeah, make the number line. Okay. And again, within these, we need to pick values. Again, for the first one, I'll just pick negative 10. Then I'll pick negative 2. It's in between there. 0 is in between that one. And 10 is within that interval. So go ahead. You can pick your own values if you want to. Those are just the values I picked of negative 10, negative 2, 0, and 10. As long as you pick a value within the interval, it'll work. Plug it into the original. Determine whether these intervals are positive or negative. Determine whether your answers are positive or negative within each interval. Alright, the first interval, furthest one on the left, positive or negative answers? Negative answers. Okay. Griffin, did you get this next interval? Positive or negative answers?
Positive.
Yep, positive. Very good. Thank you. The next interval in between the negative 0.586 and 3. Anybody get that one? You got what, sorry? Yep, negative. Very good. And last but not least, the last interval is what? Positive or negative? Positive. Very good. Okay, so we're done with pretty much all the work of it. Now we just need to figure out our solution. Yes, question?
How did you find this? Because there's nothing to, there's no factors on the bottom.
I'm still just plugging it into the original.
Okay.
So let's say for this one right here, let's check the one where I have 0. If I plug in 0 on the top, I have negative 3. If I have 0 on the bottom, this becomes 0, that becomes 0, and I just have 2. Negative 3 over 2, that's a negative number. Over here, if I had negative 2, plug in negative 2. Well, negative 2 minus 3, that's going to give me a negative on the top. Negative 2 squared is going to give me 4. So on the bottom, you might have to figure out a number if it's not factored. But negative 2 squared, that gives me 4. And then negative 2 times 4 would give me minus 8. So 4 minus 8 is a negative. So that would be negative 4 plus 2. That's still a negative value. A negative divided by a negative is a positive. So if it's not factored completely, on the bottom you may have to figure out what that value is. But on the top, you're going to know whether that answer is positive or negative. That's why if it does factor, it makes it a lot easier to do that. So this one might be a little more work. But same Same theory, the same method. Okay. So on this one, you need to go back to the original. This is very important. On this one, they're asking where it's greater than or equal to 0. So where is the interval or intervals where it's greater than or equal to 0? We need where it's greater than or equal to. I like where you're headed, Marie, but think about that specific value, negative 3.414. What is that causing our original function to do? I like your thinking, but think about that value, negative 3.414. How did we find that at the beginning? Was that numerator or denominator? So if the denominator is equal to 0, what's actually happening there? So if a denominator is 0, what's happening? Your function is undefined. So if it's undefined, it can't be equal to 0. So at that particular point, negative 3.414, it still has to be a parenthesis because at that point it's undefined. It's not 0 at that point. Okay, so you're going from the negative 3.414 to where, Marie? Negative 0.586. Parenthesis, okay. Do we have any other intervals where it's greater than or equal to 0? Yes, 3 will cause it to be 0. Very good. 3 to what? Very good. So the 3 gets the bracket because the 3 is what causes your function to be 0 at the top. So you have a bracket on the 3. Very good. Does that make sense for everyone? Why this one does not have the bracket, but this one does? This value makes it undefined. This value actually made it equal to 0. And that's the answer they're looking for. You're done with this problem. Okay? If there are no questions, we'll go to the next one. Alright, so let's go ahead and go right beside it. I'm going to erase this a little bit here so I have some room. We're going to try this one right here. So again, it needs factored. Well, it already is factored for us, so we don't have to worry about that. But we do have to list out where it's equal to 0 or where it's undefined. So my x values are what? Makes it a little easier because it's already factored. Set each factor equal to 0 and solve. Very good. Negative 1/2, positive 3, and negative 2. Again, that's just from setting each factor equal to 0. With every other problem we've done, you draw a number line. Again, we need positive and negative in the intervals. You can choose any value within the interval. The numbers I chose were negative 10, negative 1, 0, and 10. You can choose whichever values you want to. Those are the ones I chose. Determine whether the intervals are negative or positive. So take a minute, go through whether it's negative or positive, and we'll check those. This one you need to be a little bit careful when you're plugging in values because remember the factors aren't alone. 2 of them have a square on it. So make sure you take that into account. Alright, in the first interval, like I said, I plugged in negative 10. Do we get negative answers or positive answers, Marie? Negative. Does anybody need to go through that example? If you do, don't be afraid to yell. We'll go back through it. The second interval, negative or positive? Negative, very good. Okay. Third interval, I plugged in 0. Positive. And last interval?
Positive.
Positive. Okay, very good. So we did the work there. We plugged everything in. We did the hard work. Again, now you look at your original answer. If you want to go back up, put a box around it, circle it, because you know that's what you want to look at now after you've done the work. We want to know where our problem is less than 0. So the interval or intervals where it's less than 0. All right? Very good. Why can't I include any brackets? Yeah, it's not equal to 0, it's just less than 0. So if it was less than or equal to 0, you could possibly have some brackets in there, but it's just less than 0, so all parentheses. Getting a little easier? Alright, so we have one left here, but this one looks a little different. Any ideas on how we could start this last one? I mean, what's different from every one we've done so far? Marie? Okay, it's not equal to 0, or on one side of the inequality there's not a 0. Could we get a 0 on one of the sides? We can. How could we do that? Rebecca? If you multiply by the reciprocal, you'd be left with what, though? 1, not 0. So I like your thinking. So we know we're not going to multiply. We can subtract this away from it. So if we subtract, we would have 3 over x plus 2 minus 2 over x minus 1. That would all be less than or equal to 0. So again, does it look like the problems we've done yet? Not quite. Looks closer. We have a 0 over here. Now, what do you think we can do with these two to make it look like the problems we have done before? Marie? We are going to combine them, but not exactly with subtraction. How do you think we can combine those? Or kind of make them one term. What do we need to do with them? Common denominator. So what we can do on this one, we have to multiply top and bottom by x minus 1. And over here, we have to multiply top and bottom by x plus 2. So it's going to be x minus 1, x minus 1. Those will be multiplied. Over here would be multiplied by x plus 2 and x plus 2. So if you actually multiply those out, you would get 3x minus 3 over x plus 2, x minus 1, minus 2x plus 4 over x plus 2, x minus 1, less than or equal to 0. Now we have the common denominator, so now we can subtract. So we have the 3x minus 2x, which would just leave us with x. We have negative 3 minus 4, so that's minus 7, and they're all over the same denominator. Okay, did I lose anybody here? Are we okay with that step? We have the same denominators now, so the tops, I can subtract them. 3x minus 2x leaves me with x. Negative 3 minus 4 leaves me with minus 7. And again, they're the same denominator now. Now it looks like a familiar problem that we have done now. The top is technically factored, we just have the x minus 7. The bottom is already factored, we have x plus 2 and x minus 1. So we don't want to multiply those together, they're factored, so we already know that. So we can list the x values where it's either equal to 0 or undefined. So those values are what? Where is it 0 or undefined? 7, negative 2, and 1. Very good. And again, it's just like any other problem we've done. So go ahead, draw your number line. Pick some values in that interval. Again, you can pick any value you want. I'm going to pick negative 10, 0, 2, and 10. Determine whether it's positive or negative within those intervals. Again, you can choose different values if you want to. In case you wanted a reminder how to do it, I've done the first section up here. A negative over a negative times a negative, so negative over a positive, which is a negative answer. So the first interval, you would have negative answers. Anybody have the second interval done? Let's see. Did you plug in 0? Or did you pick a different value? Okay, so 0 minus 7, I get negative on the top. 0, I get positive, and then I get negative. Oop. So I get negative over negative, which is what? Positive, yeah. Be careful, a positive times a negative makes the bottom a negative, so a negative over a negative is a positive. Third interval. What did we get for the third interval? Negative. And last but not least, positive, yes. Okay, now, we can't necessarily go back to the original here because we need to think about the one that we actually found that looks like the problem we're trying to solve. So, it is less than or equal to 0 is what we're looking for. So, looking at our chart that we made, or our number line, and looking at our original here, what interval or intervals is it less than or equal to 0? Go ahead, Marie. Very good. Again, the 7 gets the bracket because that's the value that makes your original one 0. The other ones are parentheses. So we're cutting it close here, but we are almost out of time. You have a couple minutes. So this wraps up this first section here. So you can go ahead and work on the homework for this section. We are going to start with the next section tomorrow, but we did have enough time. We finished up those examples. All right, so if you have any questions, you can see me later if you have any, or tomorrow or after class.